All right, fifth video, we are on number 32. The population of a city is studied over time and modeled by the equation P of T equals blah, 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 where T is the time in years. What happens to the population during the first 4 years? So, what we want to do is find what happens after 1 year, so finding P of 1, and then what happens after 2 years, so finding P of 2, and then I'm just going to continue like that for the first 4 years. So P of 1, we're replacing the T with a 1. So 9750 times 5/8 to the power of 1. Again, calculator work. Make sure you can work your calculator property. This one is 6093.75. And then 9750 times 5/8 to the power of 2. And this one is 3808.59. And then 9750 times 5/8 to the power of 3 for 2380.37. And finally, times 5/8 to the 4th is 1487.73. And so what happens to the population? It decreases each year. What did I write? I wrote it decreases each year unit after 4 years. The I don't know what I was trying to say, but let's write this out. It decreases each year. I think I meant to say until year 4, the population is 1487. I'm not going to round up, just keep it 87. There we go. Number 9. A microbiologist is studying bacteria culture and determines that the population can be modeled by this equation. T is the time elapsed in hours. If the microbiologist begins an experiment at 10 a.m., what will the bacteria population be at 2:30 p.m.? Round your answers to the nearest whole number. So from 10 a.m. to 2:30 p.m., how many hours is that? 10 to 11 is 1 hour. 12, 1, 2, that's 4 hours. And then another half hour, so 4.5 hours. So that is our T, time in hours elapsed. So P is equal to 248 times e to the power of 0.48 times 4.5. And this is 2150.44. And rounding that to the nearest whole number, 2150. Graph the function and its inverse. All right, so let's graph the function first. So logarithms have a vertical asymptote, and then they will make some marks here. They will cross 1 unit over. This is if there's no shifting, left, right, up, or down. And then, so the left side goes towards the asymptote, and this side curves off like that. That's all logarithms. So for this particular one, so there's no number being added or subtracted in the argument, and there's no number out here, so it's not going up or down or left or right. So that means our asymptote is through the 0. And then to get my numbers, I'm going to erase that. We've got to use our calculator to plug in x values. And so we're plugging in x values. What x values? Well, we know our graph is on the right side of 0, so I'm going to plug in 1, 2, 3, maybe some more. And I don't, shootsies, I don't have my good calculator, so I'm going off of using my phone. So let me pull that up. And so my phone does not do, it only does log base 10. So I'm going to be using the, what's it called? Change of base formula. So plugging it in straight, plugging in x is a 1, log base 5 of 1. So you can put the, since it's a 1, that means 5 to what power equals 1. So I know this one is 0. But if I used my calculator, I would type log of 1 divided by the log of 5. And it'll come out to be 0. And then plugging in a 2 for the x would be log of 2 divided by the log of 5. And that is what I'm going to calculate right now. So log of 2 equals divide log 5 equals 0.4. Plugging, okay, so let's get those on there. So over 1 up 0. Stop it. Over 1 up 0. Over 2 up 0.4. Plugging in a 3 is log of 3 divided by the log of 5. Log of 3 equals divide log 5 equals 0.7 over 3 up 0.7. So I'm just going to skip over a bunch. Maybe I'm going to go over to 7. So log base 5 of 7 with the change of base formula would be log of 7 divided by log of 5. Oops. Forget to push clear, and then I have to, don't get stupid. Alright, so I'm going log of 7 equals divide log 5 equals 1.2. So this is rising very slowly, over 7 up 1.2. So that looks good enough. And we know this side of it is just getting closer and closer to the asymptote. So there is our log function. Now we also want to graph its inverse. So we have to find the inverse of y equals log base 5 of x. So we make the y an x, make the x a y, and solve for y. How do we solve for y? The y is the argument of a logarithm. So this is obviously a logarithmic equation. So we're going to convert the log to an exponent. Remember that the base is the base. So 5 to the x is equal to y. And so written normally, we're graphing y equals 5 to the x. So it's exponential growth. Its asymptote is horizontal through the origin. and then just plugging in some values like we did before. So if I plug in a 0, 5 to the 0 is 1. If I plug in a 1, 5 to the 1 is 5. If I plug in a 2, 5 to the 2, 5 squared is 25. So this side of it, it will be going up, 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 not up till way up at 25 does it reach over at the 2 mark. So I'm going to keep this line in between the 1 and the 2. And then the left side just slowly gets closer to the asymptote. And see how they're mirror images about the y equals x line? Y equals x. And you can see they are mirror image of each other. So there you go. State the domain and the range of this function. Okay, so this one does have some shifts. So inside the parentheses, +1 means to the left 1, and -5 is down 5. Down 5. So I like to do a little sketch, so that helps me. So we're going, this is a logarithm, so the asymptote is up and down, and it's to the left 1. So there's my asymptote. I didn't do it dotted, I just did solid. And then, so if there was no down, we would go over 1 and then draw it like this. But we're down 5. 1, 2, 3, 4, 5. So I need to extend my asymptote. There we go, and there we go. Domain and the range. Domain is left to right in interval notation. So we're staying on the right hand side of -1. So parentheses -1 to infinity. And the range, forever down, forever up, -infinity to +infinity. Condense the following expressions. I'm just going to check the time really quick. 12 minutes. What are we doing? Condensing this guy. Alright, so first I want to take any multipliers in front and write them as exponents. Natural log of a to the 4th plus natural log of b to the 3rd minus natural log of c squared. This one already, it wasn't in front, it was already an exponent. And you've got to recognize the natural log of e is equal to 1. The natural log of e to some exponent, say m, is equal to m. Because what we do is we can take that 6 and throw it in front, 6 times natural log of e, and the natural log of e is 1, so 6 times 1 is 6. Alright, and now I've got 3 natural logs that I can now combine. So the natural log of, so we've got a plus between the a and the b, so those will be multiplied, a to the 4th, b to the 3rd, and then I'm going to put a fraction bar because this one is minus, so it goes to the bottom, c squared, and then my plus 6. That was condensing, and now we're going to expand. Alright, so I just need a lot of room here. So we have the log of 4 plus the log of x squared plus the log of y cubed and then minus, because these are all getting multiplied, and then we divide by z to the fourth, so that'd be minus the log of z to the fourth. And then I'm going to throw my exponents to be in front to be multipliers. So log of 4 plus 2 log of x plus 3 log of y minus 4 log of z. Expanding. 37 is solving. So I would check with my calculator that I could make this be a base of 9 or a base of 3 because I can write 9 as 3 squared, but it turns out it doesn't work. And so now we have a couple choices, and the one we did most was we took the log of both sides. So that would be log of 9 to the x equals the log of 347. And with our properties of logarithms, I can now drop that x to be a multiplier in front. Equals log of 347. And so the x is being multiplied by the log of 9, so we're going to divide it. So x is equal to the log of 347 over the log of 9. That is our exact answer. And with the, never mind. I was just recalling the test we took. It asked you to say the answer with not decimals, the exact answer. Then when you put this in your calculator, that's when you go rounding it off. And I only have this going out 2 decimal places. I don't know why, but 2.66. Actually, let me try it again with my calculator, see? Because usually with logarithms, you go out 4 places. So the log of 347 equals, divided by log of 9 equals, it's 2.6621. And I'll do one more. Solve. And we've got logarithms. So when you have a log on each side, you can set the arguments equal to each other. But on the right hand side there, I've got to condense that first. Log base 7 of 3x plus 14 is equal to, there's a plus, so I can combine those with multiplying x times x plus 8. And so now I've just got one logarithm on each side, so now I can put the arguments equal to each other. 3x plus 14 is equal to, I'm going to go ahead and distribute, x squared plus 8x. It's quadratic, so I want to put everything on one side. Since my x squared is on the right, I'm going to move these guys to be on the same side. So 0 is equal to x squared plus 5x minus 14. And now I can factor. And I'm also going to put my equal 0 on the right. I like it on the right instead. And let's see, this would be a positive 7 and a minus 2. So x plus 7 equals 0, so x is negative 7. X minus 2 equals 0, so x is equal to 2. And I'm just going to quickly look at my original to see if they both would work, because remember, you can't have a negative argument. And so on this one, if I replaced x with negative 7, that gives me a negative there. So on this one, it's fine. Negative 7 plus 8 is 1. and negative 21 plus 14, also a negative on that one. But if you just have one of the logarithms in the original equation gives you a negative, then you have to take that answer off. And so x is only equal to 2. And I'm going to stop there for video 5.